So now we have an object, a mirror, and a lens. And we're combining the effects of the mirror and the lens. And you're standing way out here on the, that's you, way out here on the right side, looking back through the lens toward the object. And we want to know, what do you see? So what's happening is the object, let's say it's giving off light. Some of the light it gives off is going to go to the right through the lens to your eye, and that's going to be creating one image. And some of it is going to go to the left. It's going to bounce off the mirror, create an image from the mirror, and then that image will act as an object for the lens, and you'll see a second image. So you'll see two images, and we want to know what they are, where they are, how big they are, etc., etc. So let's get started. I'm just going to redraw this, I think, and do all my ray tracing in a new drawing. Here we go. So we are only interested in the light coming directly from the object, traveling to the right through the lens. And let's see, we need to draw a line. Let's start with, why don't we do a red line? And I'm going to do 3. The first one I'm going to do comes in to the lens parallel to the axis of the lens. So that comes in like that. And it comes out as if it was coming from the focal point. So the light comes in this way, the lens makes it diverge, comes out this way, and then we trace it back as if it came from the focal point of the lens. The second one I want to draw is going to come toward the focal point on the right. So it's coming in this way toward the focal point on the right. But when it gets to the lens, it gets diverted. It comes out parallel to the axis. And then we trace that back to see where it intersects the previous line. And there's one more we can draw. How about green for the last one? And it goes in right through the center of the lens and comes out undisturbed, the other side. Something like that. So it goes right through the center of the lens and is undeflected, and we trace back, and we see that all 3 of these lines intersect in one location. And so it's as if the light is coming from that spot right there. So that's our ray tracing. We looked at, I like to do 3 just to make sure they come close to intersecting in the same place. It's a little hard sometimes. A lot of you draw a very small diagram or aren't careful when you're drawing these, and they end up intersecting in several different locations. But try to be careful, draw a big enough diagram, and try to be careful enough so that they intersect in roughly the same location. So that's where we expect our image to be, and let's plug in the numbers and see how close we came. So our equation, 1 over the object distance plus 1 over the image distance is equal to 1 over the focal length of our lens. And we know that the focal length of our lens, it's a diverging lens, so it's -5. The object distance is positive 10, and we plug those numbers in, and I get an image distance of negative 3.33 centimeters. So that tells me that the image is on the left side of the lens, and it is virtual. Right, the rays of light don't intersect at the image. They diverge, and it's as if they're coming from an image on the left side of the lens. That's a virtual image. And negative 3.33 centimeters. So let's see where we ended up here. This is my scale here. I guess I should tell you what my scale is. Did I indicate it up above? Oh, yeah. Our scale, my scale here, 2 lines make 5 centimeters. And so I've put in here the focal length of the mirror, and the location of the object, and the location of the lens, and actually the focal lengths of the lens are also marked here. So that's all based on 2 grid lines on my sheet here being 5 centimeters. So this is 2.5, and this is 5. So yeah, could be 3.33. That's actually pretty close for my artistic ability. And let's see about the height now. We expect the height of our image to be much smaller than the height of our object. And let's see what it is. There, we have to look at the magnification. Magnification is negative S prime over S. And I came up with positive at 1/3, 0.333. And the magnification is also equal to the final height of our image over the height of our object. And so when I use that, I get our object height divided by 3 is our image height, or our image is 3 centimeters. And let's see if that works out. Yeah, it's pretty good. So this would be 2.5 centimeters, and it looks like we're just a little above that. So yeah, 3 centimeters, not bad for a drawing here, rough and dirty, ray trace. We came up pretty close to what this image is going to look like. So what I'll do now is stop the video one more time, and we'll redraw this, and then we'll look at the light going to the left through the mirror.